We're going to be graphing trig functions, and when I originally wrote this, the instruction said do 2 periods, but there's really not room for 2 periods, so we're just going to do 1. I changed it on the website, so next year we won't have that problem. So first, we're going to have something that looks like this. I'll lock that. The first one is the cosine of theta, which goes from 1 to -1, and then this would be pi over 2, pi, 3 pi over 2, and 2 pi. And then the cosine is going to look like that. Okay. Any questions about that one? Uh-oh, I lost my other. Oh, I know where it is. It's in the scanner. Okay. Number 2, which is right below it, is the sine graph. And the sine graph uses the same divisions, and it's just going to look like this. Oops, there. So the sine of theta looks like that. Any questions about that? Okay. Number 3, 2 cosine of theta. What's the difference? The amplitude is now 2, and then it's just that regular cosine. And you'd need to put the angles in there. Okay. Number 4 is 1/3 sine. So now the amplitude is 1/3, so we only go up to here and down to here, but it's the regular sine curve. Oops. Like that. Okay. And then number 5 is a little bit tricky. 5 says the cosine of theta over 2. What is that going to change? That's going to change the period. And the formula is the period is 2 pi divided by b. And b is the number inside there with theta. So what is b in this case? It's not 2, it's 1/2. So 2 pi divided by 1/2 is really just 2 pi times 2 over 1, and I get 4 pi, which means the end of my period is now 4 pi, which means halfway through would be 2 pi, and then this would be pi, and this would be 3 pi, and it's just a regular cosine from 1 to -1, here, 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 and here. Everybody understand that? Okay. Number 6, the sine of 3 theta. My period is 2 pi divided by 3. So my endpoint is 2 pi over 3. And I think the easiest way to build these is to do the end, then the middle, then the first mark, and then you can go back and do the third mark. So if I know that this is 2 pi over 3, what would that be? Half of 2 pi over 3. And you either cut the top in half if it's an even number. If it doesn't cut in half, then you just multiply the bottom by 2. So the halfway point is going to be pi over 3, which means this one is going to be half of pi over 3. So we double the bottom, and I get pi over 6. And then I can iterate this 1/6, 2/6, 3/6, which simplifies to be pi over 2. And then it would just be a regular sine graph that hits those points. Okay. What about 7? So the amplitude is 4, and it's upside down. So the cosine is upside down. Okay, number 8 is also upside down, but we change the period. It would be, yeah, half of 3 pi would be 3 pi over 2. So if you want to cut a number in half, cut the top in half or double the bottom. All right, what about number 9? 2 cosine of pi theta. So B is pi. So the period is 2 pi over pi, which gives me 2. 2 what? 2 radians. And radians are linked to the radius of the circle. So this angle is equal to 2 radiuses of the circle. So if I have a circle and I have my radius right there as 1, that would be 1 radius, and that would be 2 radiuses. So it's somewhere in quadrant 2. But we don't really care where it is. I know that the period ends at 2. So this one would be 1, and this one would be 1/2, and this one would be 3/2 or 1.5. Okay, number 10. Your B value is 1 over 2 pi. So the period is 2 pi over 1 over 2 pi. Flip and times. 2 pi over 1 times 2 pi over 1 is 4 pi squared. So that is the end. 4 pi squared. So what would the middle be? 2 pi squared, and then pi squared, and then 3 pi squared. Does that make sense? Okay, if you go to the next page, cosine of theta minus pi over 2. How is this going to alter the graph? It's going to shift it to the right. Now this is called a phase shift. When you keep the frequency or the period the same and you just slide the graph right or left, that's called a phase shift. They do it in electricity all the time. So what I'm going to do is graph the original function and then show you how it's shifted. So amplitude is 1. My period has not been altered. So pi over 2, pi, 3 pi over 2, and 2 pi. And we're going to go from 1 to -1. So here, 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 and here. But I need to move in the opposite direction of -pi over 2, which means we move to the right. So this point is going to travel to here. This point moves to there. This one moves to there. And this one moves to there. But I'm still missing a 0 radian point. So I kind of have to see this is what's going to move to there. And then I graph that. And what do you notice about that graph? It's the sine. So pi over 2 is 90 degrees, right? So the cosine of theta minus 90 is equal to the sine of theta, which we already knew, because in a right triangle, if this is A and this is B, we know that the sine of A is equal to the cosine of B. And how do A and B relate? A and B add up to 90, right? Well, if that's a right angle, you can't draw a very good triangle. So the cosine of A minus 90 is equal to the sine of B. It always works. Okay. Let's do a hard one. Let's do number 14. -2 sine of theta plus pi over 6. Okay? So my period is still 2 pi. So 2 pi, 3 pi over 2, pi, and pi over 2. And my amplitude is from 2 to negative 2. It's upside down. So the original sine graph is going to hit here, 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 and here, because it's upside down. How far are we going to shift it? We're going to move it left how far? Pi over 6. So let me get a new color. So I'm going to move here to pi over 6. And that's going to be my starting point, which means I'm not going to have a point at pi over 2. It's going to be pi over 6 to the left of pi over 2. You guys understand that? So this is negative pi over 6. What is pi over 2 minus pi over 6? So basically 1/2 minus 1/6 is 1/3. So right here, this point is pi over 3. And I'm going to go from here to here. Where's my next point going to be? Pi minus pi over 6. What is pi minus pi over 6? 5 pi over 6. And that's going to be this point. Okay. My next one is going to be 1/6 to the left of 3 pi over 2. So 3 over 2 minus 1, not divide or multiply, minus 1/6 is 4 pi over 3. And then I'm not going to go all the way to 2 pi. I'm going to be 1/6 to the left of it, which is 11 pi over 6. So this would be 11 pi over 6. Okay, so that one doesn't hit the normal, it doesn't hit the origin, so it doesn't hit those other 4. I just drew it bigger. Yeah, scale is not important on any of these. Yeah, just the critical points. So we call those 5 points critical points. Critical points are either where the sine graph hits the x-axis or where there's a relative max or min. Okay. In calculus, you'll get a better definition of critical points, but for this class, that'll do. Okay. Good luck.